Welcome everyone. In this video lecture, we will solve this question in which we have to think about the mode of operation. Okay. So in this question, there is a BJT with beta value 50 and VBE 0.7 volt and VCE set saturation collector to meter voltage 0.2 volt. So the circuit is given. RC value is unknown here. RB value is known. 5 volt is given to the base in and to collector in VCC 10 volt. So we have to think which statement is correct. So the first option is for RC 1 kilo ohm the BJT is operating in the saturation. For RC 3 kilo ohm BJT operating in the saturation. Third option RC 20 kilo ohm BJT is operating in the cutoff region, or RC 20 kilo ohm BJT operates in the saturation region. Okay, so we will start with the basic. What is the given item? Given is beta 50, VBE 0.7 volt and VCE saturation 0.2 volt. Okay, so here we can see that this value is plus or minus VBE, or we can say this end is our base in, emitter in and collector in. So if we apply simple KVL in loop 1, so it will give the value of IB. Okay, so what we have to write for this, we can write 5 minus IB times RB minus VBE equals to 0. Just applying KVL in loop 1. I am writing KVL in loop 1. Okay, so we can find 5 minus VBE equals to IBRB. Okay, or in general we can say the IB value will be calculated as 5 minus VBE is already given 0.7 by RB, that is 50 kilo ohm. So the value will be 4.3 by 50 milliampere. Okay, so the IV value is given, but we cannot find the value of value is given. So we can also find the value of IC. IC simply our beta times IB. So beta is 50. Okay, so 4.3 divided by 50 milliampere. So this IC value will 4.3 milliampere. Okay, so IB is there, IC is there. Now in our question, VC is set is given, means saturation voltage is given. Okay, so this plus of minus VCE saturation is given 0.2 volt. So we can find the value of maximum saturation current, that is our IC set. Okay, so for this IC set, if we apply Kirchhoff's voltage law in this section, so we can write VCC minus IC set into RC minus VCE set equals to 0. Okay, so it should be 10 minus IC set. So IC set RC minus 0.2 equals to 0. So we can write as 9.8 equals to IC saturation RC. But here both the term IC set and RC are unknown. Okay, so in this question we are looking for the operation and what should be the RC value. So before that I want to also give a brief for linear region operation. for linear region of pressure, base emitter junction. I am writing base emitter junction. Okay, and here I am writing base collector junction. That thing we have to remember. For linear region, it should be forward biased, and this should be reverse biased. Okay, for the saturation region, for the saturation region, both will be in forward bias. This will be also forward bias. Okay, and cutoff region, both will be in reverse biased. So this one is also an important thing that we have to know. Okay. Okay, base beta junction, then after linear, then saturation, then cutoff. Okay, so that thing we have to also know. Okay, so now we have already find the value of IC, and there is a relationship between IC set and RC. Okay, now for the time being, we can say the VBE, the base emitter voltage, will be followed by, so VBE, that is our VB minus VE, is our how much? 0.7 volt. So it is positive. So the base emitter junction is in forward biased. Now we have to think about base collector junction. So we can write VBC. So VB minus VC. Okay. So here the VB value, VB value in our case is 0.7 volt. Okay, and VE is 0 volt because it is grounded. So this VE is 0. So VB is 0.7. Okay, so VB is our 0.7. So we can write 0.7. Now VC is not known to us. So now we are just thinking for the saturation, VC set is given. So it should be 0.7 minus 0. How much? 0.2, I think. 0.2. So it is 0.5 volt. So it is also positive. So it will be forward biased. Okay. So one can say transistor may operate. I am saying may operate in the saturation because region, because base emitter junction is forward bias and base collector junction is also in the forward bias. So we can say this one is in the saturation region. Okay, just we are investigated something that this one is in the saturation region. So now what next? So if we can say the IV value is known to us, that is our 4.3 by 50 milliampere. Now for IC saturation, the saturation current, IC saturation is, we can say, 9.8 by RC. Now there is a very fundamental concept that if we increase the value of IB, if we increase the value of IB, if IC increases, so we are saying that this one is in the linear region, linear region. Okay, because IC equals to beta times IB, like that. Okay, now in for the saturation, if we are giving increasing IB, but IC saturation becomes fixed for a particular IB. So that IB, I am saying IB minimum. After that IB minimum, if this IB value will increase, no problem. IC set will be constant. So for the saturation region, we can say the IB value will be greater than IB minimum. Okay, IB value will be greater than IB minimum for the saturation region. Okay, so what I am saying, the IB will be greater than IB minimum. So IB value is already known to us. That is our 4.3 by 50 and greater than IB min. So IB minimum we can say IC set, because this formula we are using IC is equal to beta IB. So now we are saying IB minimum. So this will be our IC set. So IC set by beta. Okay. Now this value IC set, we have find the value of IC set as 9.8 by RC. So we can write this as a 4.3 by 50 greater than IC set, that is our 9.8 by RC into beta. Okay, so this 50 cancel out. So this RC value will be greater than 9.8 by 4.3. So we can find this RC value. RC value, if we divide 9.8 by 4.3, it will come 2.23. So for saturation region, the RC value will be greater than 2.23 kilo ohm resistance. So which one will be the answer for this one? We can find. So in saturation region, RB value is greater than 2.27. So the correct answer will be this option number B, RC 3 kilo ohm. So now one more way to just investigate the same thing. For now, RC greater than 2.23 kilo ohm, it is in the saturation region. Now for the time being, I am saying RC is our 3 kilo ohm for just test. Okay. Now RC is 3 kilo ohm. So we can find the value of VC. Okay. So again, I am just doing the same thing. VCC, RC. Now we are saying this. Now we are saying that VCC, RC, IC. So we can write VCC minus ICRC minus VCE equals to 0. Just writing KVL. Okay. So this value will be 10 minus IC into RC is 3 kilo ohm. Okay. Minus VCE. So I am writing just as VC because E is 0. Okay. So or we can write simply VCE equals to 10 minus 3 kilo ohm into IC value. IC value will be how much? IC IB is given, so IC is 4.3. 4.3. So 10 minus this will be 3 into 4. Okay, 9 into 12.9. So it should be negative value. Okay, so VC value will be negative. So VBC base collector junction, VB minus VC, VB 0.7. Now this VC, because this VC will be our negative term, 2 minus 2.9. So it should be minus 2.9. So it should be plus. So VBC is still a positive value. So it is in the forward bias. If we take R equals to 1 kilo ohm, for R equals to 1 kilo ohm, for R 1 kilo ohm, for if we take VBC value will be positive, okay, VBE value will be also positive, so it is in the saturation. Now for 1 kilo ohm, if we are taking 1 kilo ohm, we can write VCC. So VCE value will be 10 minus this value 1 kilo ohm. Okay, 1 kilo ohm into 4.3, 4.3 milliampere. So its value will be plus 10 minus 4.3. So how much it should be? 5.7 volt. So VCE value is positive. So VCE value is positive, that is our 5.7. So it should be VC minus VE. VE is grounded, so VC value is 5.7 volt. So now here we can find if VBC, VB minus VC, that is our 0.7 minus 5.7. So it is in negative. So for 1 kilo ohm, VBC will be negative, okay, and VB is positive. So it is in the linear region. For this one, linear region, okay. So like that we can also think then in which region it will operate. So this is all about this question. So thank you for watching this video.